Recently, we introduced you to Le Chatelier's principle, and this is one of the most important concepts in Chemistry 12. So you should understand the principle, but you should also understand how changes in things like concentration, pressure, and temperature will cause shifts in equilibrium. So you should understand the difference between the word stress and the word shift, and we're going to try out some examples. That's why it said applied. First thing we're going to look at are concentration changes. If we have PCl5 in equilibrium with PCl3 and Cl2, all gaseous, we want to know what do these stresses do. If we increase the Cl2, the equilibrium will shift left. Therefore, our PCl5 will go up and our PCl3 will decrease. Now, if I asked you about the Cl2 concentration, the wording of the question becomes really important, because overall the Cl2 will end up higher than before the stress was applied, but it will decrease after the stress. So once the stress is applied, the Cl2 has gone up and spiked, it will gradually decrease. So there we have a shift left, PCl5 increases, PCl3 decreases, and the KQ, there's no change. Concentration does not change the value of KQ. So we'll try another one. If we decrease the PCl5, well, this is dropping. Equilibrium comes over to the left to try to replace that PCl5, and therefore the PCl3 and the Cl2 will decrease. And that's what it's saying here. And again, no effect on the value of KQ when it's a concentration change. Now we're looking at another one. This is calcium carbonate in equilibrium calcium oxide and CO2. The first two materials are solid, the CO2 is a gas. Our stress is decreasing the CO2. So if that goes down, the equilibrium is going to shift to the right. The concentration of the two solids will not change because they're solid, they have fixed densities, so there's no choice. And boom, boom, boom. Now, if we asked you about the amount of calcium carbonate, it would decrease somewhat because some of it's used up, but its concentration stays the same. Same for the calcium oxide. No effect on KEQ because we're looking at a concentration change. Pressure. So here's the Haber process. We increase the pressure. 1 and 3, that's 4. Here's our 2. So the equilibrium wants to shift to the right. Oops. Now what's going to happen is if it shifts to the right, we're going to end up with the NH3. In fact, initially, all the concentrations are going to increase because we have a smaller volume. But the NH3 will continue to increase after stress, and the N2 and the H2 will decrease. No effect on the KEQ. Now we're looking at temperature effect, and this says, hey, we're increasing temperature. We can see the forward reaction is exothermic, and we know an increase in temperature favors endothermic. So this equilibrium is going to shift left. That means the CH4 and O2 will go up, and the CO2 and the H2O concentrations will go down. So hopefully it says something like that coming up. Whoa, there's our shifting left. And there's our reactants increasing and our products decreasing. So what happens to the KEQ? Well, we now have fewer products, more reactants, so we end up with a smaller value of KEQ. Temperature change will change the value of KEQ. So there you have some examples. That's what you're going to see on your worksheets, and hopefully you can explain it and it makes sense. If not, watch this again or ask questions.